Okay, welcome back. This is Dr. Vermiglio, and this is part two of our discussion on experimental designs for diagnostic accuracy studies and auditory processing disorders. So, according to the British Society of Audiology, auditory processing disorder diagnosis is based on a large number of tests, none of which have robust scientific validity, not least because there is no agreed gold standard, also known as a reference standard, against which validity can be assessed. Management strategies are consequently and similarly underinformed. This is a very interesting study by Dr. Wilson and Arnott, published in 2013. Dr. Wayne Wilson is an audiologist who teaches at a university in, actually, I think it's the University of Queensland in Australia. So these researchers did this very interesting study. They determined the percent of 150 children who received a diagnosis of CAPD using different diagnostic criteria. Now, I'm only showing you 4 of the diagnostic criteria. They actually looked at 9, but for our discussion here, we're just going to discuss these 4. So using the criteria from ASHA 2005, which is a little different from the criteria from AAA 2010, they found that out of 150 children, when they took this test battery, I think it was like 4 or 5 behavioral tests, 96% of 150 children were diagnosed with the CAPD. But when they changed the diagnostic criteria to AAA 2010, 71.3% of these children had an APD. Well, that's interesting. And then when they used the British Society of Audiology criteria, now the diagnosis rate is down to 24.7% of these children who received the diagnosis of essential auditory processing disorder. And then the guidelines, according to Dr. Terry Bellis, only 7.3% of these children were diagnosed with a essential auditory processing disorder. So which one of these should we choose to follow? Should we follow ASHA's guidelines? Should we follow AAA's guidelines, British Society of Audiology, or Dr. Bellis? How do you decide? Well, if we had a reference standard test that could tell us if the index test or index test battery results were true or false, we could make that determination. But because there is no reference standard, there is no way to determine which of these diagnostic criteria are the most accurate or the best. So this is what we're stuck with in the field of, in the area of auditory processing disorders. So this is the heart of the auditory processing disorders construct. According to the guidelines from the American Academy of Audiology, if certain test patterns have been demonstrated to have good sensitivity and specificity in adults with confirmed central auditory nervous system lesions, then one may presume a high degree of likelihood that the same pattern of test results, when observed in a child or an older adult undergoing testing for central auditory dysfunction, confirms a CAPD in that child or older adult. So basically what they're saying, if you have these behavioral tests that have been demonstrated to have good sensitivity and specificity in adults with confirmed central auditory nervous systems. Let me back up a little bit. The only way you can have good sensitivity and specificity is if you have a reference standard. And in these studies, they were not looking at the diagnostic accuracy of these tests for the detection of essential auditory processing disorder. They were looking at the diagnostic accuracy of these tests for a lesion of the central auditory nervous system. And in these studies, they actually used you could use something like an MRI nowadays to determine the presence of a lesion of the central auditory nervous system. So let me get back to our story. So certain tests are sensitive to a known lesion of the central auditory nervous system, then we're going to presume a high degree of likelihood that these same tests, when you see poor performances on these tests, they're going to confirm the presence of a CAPD. Let's look at two words here, the word presume and the word confirms. The word presume can be taken to mean to suppose to be true without proof, such as presumed innocent until proved guilty. Okay, that's the word presume. And the word confirm, the meaning can be taken to mean to give new assurance of the validity of, remove doubt about by authoritative act or indisputable fact. So I think this is problematic, where we're presuming that tests sensitive to a central auditory nervous system are also sensitive to a central auditory processing disorder. Okay, so let's go through a few of these studies. Dr. Music has done a number of these studies with his colleagues. Here's an index test used for the determination of two things. One is for a lesion of the central auditory nervous system, and it's also been used to determine the presence of an auditory processing disorder. So this test is called the frequency patterns test. This is really easy. So imagine listening to three beeps. Doot, doot, doot. So, okay, there's three tones, and there is two lower frequency tones and one higher frequency tone. Doot, doot, doot. And so you just tell the patient, all right, you're going to hear these three tones, and tell us if when you hear a low frequency tone and a high frequency tone. And the patient might respond, oh, I heard low, low, high. Or they might hear doot, doot, doot. They might hear high, low, low. And then you say, yes, that's correct. Or you say, no, that was incorrect. And then you conduct a score. And what they found in these studies is that the ear contralateral to the side of the brain with the lesion, or with the, it could be a tumor, it could be some sort of insult to the auditory nervous system on that side of the brain. This test is actually to some degree sensitive. How sensitive is it to these lesions? Well, according to the study that they did in 1982, this test correctly identified 30% of the research subjects with this type of lesion, a brainstem lesion, which included contusion, right brainstem tumor, left brainstem tumor, demyelinating disease, left upper pons, mini stroke, left brainstem contusion. So it identified 30%. Not a great performance for this test, but there it is. I believe they didn't have a control group, so they could not determine the specificity of the test. And notice that they had a reference standard for the presence of the disorder. It's unclear if they had a reference standard for the lack of the disorder, but then again, I don't believe they had a control group, so this doesn't matter. So specificity is unknown. Now, in 1987, the authors evaluated the diagnostic accuracy of frequency patterns for the detection of these brainstem lesions, right? And they had a number of reference standards. They had a neurological evaluation, radiological evaluation, surgical confirmation, or an abnormal ABR. And for the absence of the disorder, they used, yet again, another reference standard, negative neurologic history. So they found that the diagnostic accuracy of the frequency patterns test for the detection of the presence of brainstem lesions was 45%. So we would say that sensitivity was 45%. And the diagnostic accuracy of this test to identify the absence of these lesions was 88%, or we would say the specificity was 88%. And then in subsequent studies, they showed greater sensitivity, but notice that they're looking at different lesions. They're using different types of reference standards, and so it does get a little confusing. I will say that the frequency patterns test, as much as I could tell, was administered exactly the same way throughout these studies. So this brings us to the question, what is the sensitivity of the frequency patterns test for the detection of lesions of the central auditory nervous system? Is it 30%? Is it 45%? Well, that's what it is for brainstem lesions. Oh, but then for cerebral lesions, it's a little higher. So that's really interesting. Let's press forward. So here's the presumption. Behavioral tests that have known sensitivity and specificity for the detection of a lesion of a CANS, and we know the sensitivity and specificity because we have access to the results of the reference standard test. It is presumed that these tests are also appropriate and sensitive to the presence and absence of an auditory processing disorder. The only problem is we don't have a reference standard to confirm that this is correct. So can we say that behavioral tests that are sensitive to one lesion or one type of disorder, a lesion of the CANS, again, this is a clinical entity, also called a clinical entity, is sensitive to a different disorder, an auditory processing disorder? Well, we can actually answer that question in a different study. This is by Wolf et al. They looked at the diagnostic efficiency of the MRI. Notice that the MRI in this case is actually the index test or the test under evaluation. So what is the diagnostic accuracy of the MRI for neoplastic lesions? This is the type of cortical lesion. And the reference standard was neurohistopathology. So all the subjects in this study were dogs, and they sacrificed the dogs at the end of the study, and they evaluated the neural tissues. That's what this means. And they found that the diagnostic accuracy of the MRI for the detection of the presence of neoplastic lesions was 87.4%. And the diagnostic accuracy of the MRI for the detection of the absence of neoplastic lesions was 91.7%. So using the method of reasoning from the AAA guidelines, can we presume that the diagnostic efficiency of the MRI for the detection of neoplastic lesions is relevant for the detection of the presence and absence of inflammatory lesions? Well, since there is a reference standard that can be used to make this decision, we can actually determine the sensitivity and specificity. Great. Oh, look, the sensitivity is 86% for the detection of inflammatory lesions, where it was 87.4% for the detection of neoplastic lesions. So that means that the diagnostic accuracy of the MRI for the detection of neoplastic lesions appears to be relevant for the detection of inflammatory lesions. Oh, okay. So that actually confirms the guidance from AAA 2010 that the diagnostic efficiency of an index test for one lesion might be relevant for a different lesion. But let's move forward. Let's look at the diagnostic accuracy of the MRI for the detection of the presence and absence of cerebral vascular lesions. Oh, it's a little different story. The sensitivity or the ability of the MRI for the detection of the presence of cerebral vascular lesions was only 38.9%. That's not the same as 87.4 or 86%. So we cannot presume that the diagnostic accuracy of the MRI for neoplastic lesions and inflammatory lesions may be relevant for the detection of the presence of cerebral vascular lesions. Now notice the specificity was actually very high over here. But the take-home message is that we cannot presume that an index, that the sensitivity and specificity of an index test for one lesion is appropriate for the evaluation of the presence and absence of a different lesion. So here's our situation. We have behavioral tests with known diagnostic efficiency for the detection of a lesion of the CANS. We can determine this because we have a reference standard. A presumption has been made that these behavioral tests can be used for the detection of an APD, but we don't have a reference standard to evaluate this presumption. So what some of the authors have done, and you'll read about this in the response by doctors Iliadou, Shermack, and Music and Bamio, they simply stated, oh, well, all we have to do is say that the behavioral test, this battery is actually a gold standard. So all we have to do is just say that this is the gold standard. But this begs the question, how do we know that this is the gold standard? A gold standard, the term gold standard implies that an evaluation was conducted and they looked at various behavioral tests for the determination of the presence and absence of an APD, and they determined that this was the best. But how did they determine that this was the best when there's no reference standard? So this actually doesn't make any sense at all. Okay, and in the APD literature, a lot of times proponents and skeptics of APD seem to be talking over each other. It's like they're not even using the same terminology. And so let me try to clarify some of this. The proponents of auditory processing disorder will talk about two types of auditory processing disorder, but they give it exactly the same term. So they'll say a lesion of the central auditory nervous system is an auditory processing disorder. And then they'll say when there are poor performances on behavioral tests that are sensitive to a lesion of the auditory, central auditory nervous system, when we take these tests and there's poor performances on these tests, then we have an APD. Does it mean that there's a lesion? No. It's APD in the absence of a lesion. So I'm calling this APD1 with a lesion and APD2 without a lesion. And I think this helps clarify the discussion. So for APD1, we have a reference standard. For APD2, without a lesion, there is no reference standard. So look at these comments that we reviewed before. According to AAA 2010, several lines of evidence have accumulated over the last 50 years, definitively establishing CAPD as a true clinical disorder. And Aetna has stated that APD is not, in fact, a distinct clinical entity. So which is it? Well, looking at this, I think this is what's going on. When you see a statement like this, that there's several lines of evidence to establish CAPD as a true clinical disorder, they're talking about all the studies that have evaluated the diagnostic accuracy of various behavioral tests for the presence of a known lesion. How do we know it's a known lesion? Because reference standards have been identified for the detection of these lesions. But Aetna's policy is not discussing lesions of the central auditory processing, lesions of the central auditory nervous system. Aetna's policy is describing conditions where there are two tests that where the patient has poor performances on these tests, and there's no lesion and there's no reference standard. So that appears to be the story. So AAA is saying, look, there's plenty of evidence for APD1 in Aetna and other insurance policies, and it's not just insurance policies. It's a number of authors, including Dr. Moore in that controversial paper published in Ear and Hearing that are discussing this. So it's Aetna and other researchers, including speech-language pathologists. I gave a discussion with Doctors Geraldine Wallach and Dr. Alan Kamhai, who are both speech-language pathologists. And we gave a discussion on this issue regarding auditory processing disorder at the ASHA conference a few years back. And I will tell you, there was so much interest in this conference. This never happened to me before. And it's not because I was one of the presenters, it's because of my colleagues who were very well-known speech-language pathologists. But it was standing room only to this discussion. And they actually had to turn people away from the door. They sent them to an overflow room where they saw the slides. So there was a lot of interest in this discussion. So what is the solution? So this is what I have proposed in my writings. Within the CAPD construct are a number of potential clinical entities. These should be identified using the Sydenham-Gutentag criteria. The validity of the diagnostic protocols for these clinical entities should be determined using reasonable reference standards. And this should result in desperately needed clarity for the conceptualization, diagnosis and intervention of auditory disorders. So, for example, there is a disorder called a speech recognition and noise disorder, and these investigators have used various index tests for the determination of the presence and absence of this disorder, and the reference standard that they used was the self-report of the patient. Now, some of you might say, well, wait a minute, you can't actually trust the client or trust the patient to tell us if they have this condition. I mean, that's not going to work. But if you think about it, every single behavioral test in speech and hearing that requires a response from the patient relies on self-report. So pure tone thresholds rely on self-report. Certainly our questionnaires rely on self-report. Any studies on tinnitus or ringing in the ears relies on the self-report from the patient or the research subjects for us to determine if the tinnitus is present or absent. The same is true for dizziness, and the same is true for pain. Okay, so here's a study that we did. This is called an argument for self-report as a reference standard, where we use, this is a diagnostic accuracy study. Here's our diagnostic system, the behavioral tests, where the index tests or the tests under evaluation. These index tests included the binaural pure tone average and the results from the hearing and noise test. So these are our two tests under evaluation. The target condition was a speech recognition and noise disorder, and the reference standard was self-report. And we found that the sensitivity of the binaural pure tone average for a speech recognition and noise disorder was only 28%, and the specificity was nice and high, 95%, whereas the sensitivity for the hearing and noise test was 88%, and the specificity was a little lower than the pure tone average. It was down to 77%. So this is a way to determine the diagnostic accuracy of our behavioral test for the specific disorder using this reference standard. There's another thing used in diagnostic accuracy studies called the receiver operating characteristics curves. Remember that all this work has been derived from this work in diagnostic accuracy studies has been derived from the field of radar. So remember the radar receiver, that radar screen, remember the radar operator, the guy who's looking at the screen. This is where the term receiver operating characteristics curves came from. And this actually comes from a paper on radar published by Peterson in 1954. And there's also another aspect of this called the area under the curve. So if we had a receiver operating characteristics curve where you had a line that came up like this and over and this, let me say this, the x-axis, this gets a little complicated. The x-axis is 1 minus the specificity. This is the false positive results. And the y-axis is the percentage of true positive results, also called the sensitivity. So this is 1 minus specificity. This is the sensitivity of the test. And then we plot this for various cut points, and you get this receiver operating characteristics curve. Now, if the curve goes up like this and over like this, then that is represents perfect discrimination of individuals with and without the disorder. But for our bilateral pure tone average, look at the receiver operating characteristics curve. It's sort of like, loosely, it's a diagonal line. The area under the curve is 0.51, and this means that it's the diagnostic accuracy is very poor. If we had a straight line that went up like this and over like this, the area under the curve would be equal to 1.0. As opposed to the hint composite score, the diagnostic accuracy of the hint composite score, which is the average of 3 different hearing and noise test conditions, the area under the curve is a 0.87, and this is a significant predictor where the probability level is less than 0.01. So this this is a reasonable predictor of the presence of, or rather of the detection of the presence and absence of a speech recognition and noise disorder. And again, this is all in my paper from 2018. So in summary, a diagnostic system is required in order to determine the validity of a diagnostic test. A diagnostic system includes the index test, the test under evaluation, the target condition, which is the target disorder or clinical entity, and the gold or reference standard test. The reference standard is the best available test for the identification of the presence, sensitivity, and absence specificity of the target condition. A reference standard in a diagnostic accuracy study is used to determine which subjects are assigned to the control group, that is the non-disordered group, and the disordered group. Let me say this, and if you wanted to look up a diagnostic accuracy study, you can actually find diagnostic accuracy studies that do not use the term diagnostic accuracy study. It might not use the term diagnostic system. It might not use the term index test. It might not use the terms target condition, clinical entity, or target disorder. And it might not use the term gold or reference standard. So this gets a little confusing, but just know that a reference standard test, also called a gold standard, is the test used to determine which subjects are assigned to the control group, the non-disordered group, and the disordered group. So if you have a non-disordered group and you have a disordered group, and you have a test used to determine who gets into which group, that test is called the gold standard or reference standard. The index test is the other measure. It's actually the dependent variable of the specific test that, or rather, the results of the index test are the dependent variable that you're comparing between the control group and the disordered group. Okay, so now you have a diagnostic system with the index test, the target disorder, and the reference standard. When a target disorder is ambiguous, meaning it has more than one meaning or more than one definition, it precludes the procurement of a reasonable reference standard. Without a reference standard, it is impossible to determine if the positive and negative results from an index test are true or false. In other words, it is not possible to determine the validity of the index test. Diagnostic accuracy results may be reported in terms of 1, group differences, such as the paper by Middleweird, 2, sensitivity and specificity values, and 3, receiver operating characteristics curves and the area under the curve. So this is the end of part 2 of experimental designs for diagnostic accuracy studies and our short discussion on auditory processing disorders. And thanks for listening.